Hopefully you did the do now before starting the video. I plotted the vertices of the triangle ABC and now want to get the length of each side. You could find this in your flipbook earlier in the year when we did perimeter of polygons on the coordinate plane. So AC, a vertical segment, is 1, 2, 3, 4, 5, 6, 7, 8, 8 boxes or 8 units long. BC, 1, 2, 3, 4, 5, 6 is 6 units long. And then how can we find the length AB considering we can't count the boxes because it's not vertical or horizontal, but since we have a right triangle that's 6 and 8, it's a 3, 4, 5 right triangle times 2, the 6, 8, 10. So AB is 10. If it weren't a triple, what could we use to find the length of a segment that is not horizontal or vertical? Pythagorean theorem, and that's what we used earlier in the year. We could use Pythagorean theorem to find the distance between any 2 points. That's what we used earlier this year. However, Pythagorean theorem could be rewritten to find the hypotenuse, and I showed you this earlier in the year. Instead of doing a squared plus b squared equals c squared and solving for c, if you solve the equation for c, you could just take the square root of the sum of the squares of the 2 legs. Now, when you look at the length of the legs are going to be related to the coordinates. If you subtract the y coordinates of the point, that gives you the length of the vertical leg, and if you subtract the x coordinates of the points, that's going to give you the horizontal leg. And then the formula is written like this. You take the horizontal leg, which is the difference in the x coordinates of the points, and you square that, and then you take the length of the vertical leg, which is just the difference in their y coordinates, and you square that, and then add them together and get the square root. You will have a choice in every problem that we do, whether you want to use the distance formula or the Pythagorean theorem. However, for the sake of today, I want you to practice both ways so that you see what you like better. Sometimes it flows nicer with the distance formula. You don't have to draw the right triangles out. I'll show you what I mean. Find the distance between the 2 points. So if we don't have the graph, then it would make much more sense to use the formula. I thought for a second that that picture was these points, but it's not. So here you see that you would be able to use the distance formula. In the first parentheses, they subtracted -3 minus 3, x2 minus x1, that's here, and that gives you a -6. The length of the segment would always be positive, but once you square it, it's going to be positive, so it doesn't matter. When you subtract the y coordinates, -1 minus 2, that's in the second set of parentheses, you get -3, again a negative, but when you square it, it takes care of the negative, you get 45. So here they simplified the radical, which you're still responsible to be able to do. I think we should have a card on simplifying radicals. I hope so. So 3 radical 5 was the simplest radical form. And then if you put you don't have to put the 3 radical 5 in the calculator, just put the square root of 45 in the calculator, you'll get the 6.7. Either way, you'll get the same thing if you simplify it correctly. So simplifying radicals, if you don't remember how to do that, you're going to have to contact me so that we can go over that. That you could find earlier in the year also. Okay, so here again, they give you 2 points and ask you to find the distance. When you don't have the graph, you could use scrap graph paper, or you could just use the distance formula. So I'm going to use A as my x1, y1, which, by the way, these are subscripts, not exponents. Some of your work, you're writing them out as exponents, and that's incorrect. So the distance formula would be something you would have to memorize for the regions if that was happening. And I'm going to plug in to get the horizontal leg first. I'm going to do x2, which is 0, minus x1, which is 5. And to get the length of the vertical leg, I'm going to do y2, which is negative 2, minus y1, which is 4. So D equals, you can use the calculator. I just want to show you. If you're going to use the calculator, make sure you don't put the radical into the calculator, just what's underneath. So I would start with the 0 minus 5, and then outside the parentheses squared, and then plus inside parentheses negative 2 minus 4, outside the parentheses, that's not squared, and that gives us 61. So underneath the radical is 61. However, we didn't take the square root yet. So this multiple choice is being tricky by putting 61 as one of the choices. When I take the square root of 61, I get the 7.81 number. So it didn't say it around, which is a little, trying to trick you a little. Okay, so when you put it in the calculator, make sure you're just putting what's underneath the radical in the calculator, not the square root symbol. Kind of like it should remind you of last year when you were using the quadratic formula. We'd always get the discriminant by typing what was underneath the radical, never putting the radical on the calculator too. Okay, again, another one without a graph. And your homework I gave you, or the worksheet you're working on, I gave you graphs for them, so you have the option of using the Pythagorean theorem or not. Here, I'll do x1, y1, x2, y2. So inside the radical, inside parentheses, I'm going to do x2 minus x1. So negative 6 minus negative 10, which I could just put plus 10, plus, oh my God, it's thundering so badly outside, 15 minus 13 squared. You could put everything under the radical into the calculator. Oh, they're screaming. I'm going to come back to you.